take a look at examples 3 and 4 here, and I'm going to give you some ideas and some strategies to help tackle a more complicated problem involving complementary and supplementary angles. So example 3 here says the larger of two supplementary angles exceeds 7 times the smaller by 4. So in this case, we're just talking about two supplementary angles. So if we take a page from the book from problem 1, so if we take some ideas from problem 1, we could model out supplementary angles forming a straight line. So we're going to draw myself a straight angle, divide it in half, and it says the larger of two supplementary angles exceeds 7 times the smaller by 4. Well, what we figured out from before is they're telling us the measurement of the larger angle in terms of the measurement of the smaller angle. So let's call the smaller angle something. Let's call it x. So if that's the case, it exceeds 7 times the smaller by 4. That means 7 times the smaller angle, and then plus 4 more units is going to give us the measure of the larger, which would make 7x plus 4. So if I look at these two angles making a straight angle, I need to add everything together. 7x plus 4 plus x, that has to add up to my straight angle measure of 180 degrees, giving me 8x plus 4 equals 180. So let's subtract 4, giving us 176, and divide by 8, which I think would be 22, but let's double check. Friday mental math is always a risky thing. Aha, we're good. It is 22. So divide by 8, and that gives us that x is 22. Well, let's go back up. So in this case, we said that the smaller angle was 22 degrees. So that makes this one here x 22. So then all I need to do is multiply that by 7 and add 4. Well, let's see here. 7 times 22 would be 140 plus 14, so that makes 154. 154 plus 4 gives us 158. And so that means that the larger angle is equal to 158 degrees. All right, cool. So that wasn't too bad, hopefully, for you. Quick double check, do those add up to 180? Did I actually do the math right? Did I set this up right? We often have ways to check and feel good about the work we did. 158 plus 22, that's 180. I feel good about that. Okay, so then let's look at example 4. This is where things start to get a little more complicated. So example 4 says the measure of the complement of an angle is 20 less than 1/2 the supplement of the angle. That's a lot. Measure of the complement of the angle. Let's say so far, I don't really know what that is going to be, but we'll just say, okay, the complement, whatever that's going to be, whatever measure that is, or if I want to use variables, the complement is, remember that is represents our equal sign. So the complement is going to equal 20 less than 1/2 of the supplement. Well, 20 less than, it's a tricky one for people. This means take a quantity and remove 20 from it. So subtract 20 from that quantity, and then 1/2 of the supplement. So that would be 1/2 times the supplement of our angle. Okay, so then it says find the measure of the complement. So here's the deal. Do I know what the measure of this angle is? I don't. They just gave me a general angle. So let's make for ourselves the key for this problem off to the side. So I have a general angle, and then in this problem I use the complement and the supplement. So I'm going to say that my angle itself is x degrees. So if my angle is x degrees, we just talked about this at the end of class. That would mean the complement in terms of x, meaning using x to find the complement, would have to be 90 minus that angle measure, 90 minus x degrees. And together, if I add x plus 90 minus x, that does give me 90. The supplement is going to be, same idea, but using a measure of 180. I want to take 180, subtract my angle, so that makes this 180 minus x degrees. Okay, so now, in order to solve this equation, I like this because it gives me some actual variable to solve for. It gives me, even though I don't know the angle, I now have some expressions to work with. So if the complement in terms of an angle x is 90 minus x, I can replace that into my equation to make this 90 minus x equals 1/2, and then the supplement, we said that's 180 minus x. So 1/2 times 180 minus x minus 20. Okay, cool. Well, now I have something where I have a variable in it. What I can do is if I solve for x, that's going to tell me what my original angle was, which then allows us to figure out a numerical value for the complement and the supplement. This is a specific angle out there. There's only one of them in the world that is going to have a complement that's half of its supplement minus 20. So looking at this, we need to solve this out. So what I'm going to do is I'm going to add this 20. And I'll show you why in just a second. Some of you are going to go right to distributing this 1/2. That's fine. Nothing wrong with it. I just like getting rid of fractions if I don't have to. It's up to you. You might actually find your ways easier than mine, but this gives me 110 minus x equals 1/2 times 180 minus x. So now what I'm going to do, just by preference, is multiply by 2 on both sides to get rid of this 1/2. What that does when we distribute it is it gives us 220 minus 2x equals, now the half is gone, 180 minus x. So then I'm going to add over the 2x and subtract the 180, and that gives me x is equal to 40. So, okay, that means, working this out, going back up to our problem, that our angle is 40 degrees. That would make the complement 50 degrees, and then that would make our supplement 180 minus 40, that would make it 140 degrees. Well, let's try this out. The complement is going to be 20 less than half the supplement. So if I take the supplement, cut it in half, that's 70 degrees. If I subtract 20 from that, is that 50? It is, so that works. So to answer our question, that means our angle is 40, and the complement of our angle is equal to 50 degrees. So to summarize here, because you're going to see this show up on your homework in problems, let's see here, in problem, let's see, it looks like in problem 5 we'll have something similar to that, maybe in problem 16, and then also we'll work with some more of these as we start class next week. So this will give you an idea if you want to try this out on your own. I'd encourage you to take a look at some of the more challenging problems like 21, 22, 23 in your textbook, to try this on your own and to look at your answers from there. So hopefully this gives you a better idea how to tackle some of these problems, work on these over the weekend, and then we will go over questions and work through this some more on Wednesday.